Hello students, this is a video on lesson 100, graphing parabolas. If you will turn to page 416, we shall get started. All right, so to begin with, we need to say, what is a parabola? A parabola is something that is graphed that either looks like that or graphed looks like this. And this is called opens up, this is called opens down, all right? So what type of an equation looks like this? It's always a second degree equation, a quadratic, something that looks like y equals ax squared plus bx plus c. That is what the equation looks like in its standard format, all right? So this is standard format. We're going to also look at another format. It's called the vertex form. The vertex form of the equation is y equals, a is outside the parentheses, it's x minus h squared plus k. All right, now looking at these equations, I want us to note some important things about this. We'll always start in the standard format, our equations. And we'll ask ourselves two questions. We'll ask ourselves, does it open up or down? And what is the y-intercept? All right, the a value tells us if it opens up or down. If a is greater than 0, it's going to open up. In other words, if a is a positive value, it's going to open up. If a is less than 0, then it's going to open down. In other words, if a is negative, it opens down. So that's one thing we're going to ask ourselves, all right? A second question we're going to take note of is the y-intercept. What is the y-intercept? The y-intercept is where this graph will cross the y-axis. The c value tells us where it crosses the y-axis. So your y-intercept will be 0 and the value of c. Now, we'll always start out in standard, all right? We are going to transform this equation to vertex form by completing the square. I know, I hear the grumbling. Complete the square. But this vertex form is going to give you what the name tells you, the vertex. You cannot graph a parabola without knowing the vertex, because you have to know the lowest part. If it opens up, here's the vertex. It's the lowest part. It's the minimum. It's where the graph ceases to decrease and begins to increase. So you have to know where that changes. Or it will give us, if it opens down, it'll give us the maximum, where that graph ceases to increase and begins to decrease. All right, so this is our vertex. This min and this max, that's where our vertex will be. All right, now, if I just had y equals x squared, the vertex lies at the origin of the coordinate system. All right, but because I don't just have y equals x squared, I have a, I have bx, I have c. We have transformed it. What does that transform mean? I've moved that vertex left and right and up and down, all right? The h value moves it left or right. If it's minus h, it moves it right. If it's plus h, it moves it left. So it's just the opposite, right? Our x transformations are always that way because of the standard format of the original equation, all right? If k is positive, it's going to move it up. So it's the y transformation. If k is negative, it's going to move it down, all right? So our vertex in this form, our vertex is going to be the value of h and the value of k. All right? So let's do problem 100. All right? Example 100.1. And I'm going to write over here what the vertex is, because I'm going to show you another formula that's not in your textbook after I teach this lesson. All right. So we have y equals x squared minus 4x plus 2. All right, now you'll understand why I taught you completing the square the way I'm going to do it now, because you need to get it in vertex form as opposed to the way the book taught it. So I'm going to isolate the 2 before I complete the square. So I'm going to leave x squared minus 4x in parentheses and move the 2 outside the parentheses. But what I do on this side of the equal sign, the net effect must be 0. Otherwise, I change the value of the equation. All right, so I take the b value, which is negative 4. I take half of it and I square it. That's negative 2 squared, which is 4. So because I've added 4 in here, I have to subtract 4. And I'm going to subtract the 4 out here. All right? This value is going to give me my k value. All right, so then I have, remember I have my binomial, right? And what I add or subtract to x inside the binomial that's squared is the value of b over 2. And that is negative 2. And then I combine these terms out here, negative 4 plus 2, which is negative 2. So now I have my vertex. Okay, here's what you got to get in your brain. The vertex is opposite, same. 2, negative 2. 2, negative 2. The opposite value, the same. It's because of the standard format is a negative here. So this is really minus a positive 2. So the value in the place of h is a positive 2. All right, that's my vertex. It opens up. I got to go back to the original equation to answer these two questions. Does it open up or does it open down? That's a 1. It's greater than 0. So it's going to open up. All right. Now, where is my y-intercept? Where's it going to cross the y-axis? It's going to give me a coordinate point. It's 0 and my c value, which is 2. All right, so I have all the key information that I need to be able to graph this. All right, so drawing my x and my y-axis, I'll label some points. All right, I'm going to graph the vertex. The vertex is at 2, negative 2. All right, I also want to make another point here. At the x value of the vertex, I have this axis of symmetry. So I have an axis of symmetry at x equals 2. Why is that important to note? Because what is an axis of symmetry? It's actually the mirror. And what we see on the left-hand side of that axis of symmetry should be a mirror image of what is on the right-hand side. So if I can graph 0, 2, where it's going to cross the y-axis, and here's my mirror, my axis of symmetry, I can go the exact number of units to the other side of that axis of symmetry and plot a point. All right, so if this is 2 units to the axis of symmetry, I can go 2 more units on the other side of my axis of symmetry to plot a point. And I have enough points to be able to graph my parabola. All right? So I needed to know open up or down. I needed to know y-intercept. I get that from the original equation. After I complete the square, I find the vertex. All right, and that's when it's open up. Open down is a slightly more difficult. So we'll do example 2 on the top of page 417. And we begin with y equals negative x squared plus 2x plus 2. Plus 2x plus 2. I forgot to write my vertex. 2, negative 2. All right. I'm going to write my vertex. I don't have anybody here to remind me. Okay. First, also, I'm going to, let's answer these 2 questions. Does it open up or down? Well, there's a negative. So it's going to open down. All right? Where is my y-intercept? It's going to be at 0, 2. All right? So I've answered those first 2 important questions. Now I'm going to isolate the 2. All right, now what's important at this point is this negative changes a few things, all right? I'm going to first factor the negative out of what's inside the parentheses. So I have y equals negative x squared. It changes both of the signs inside the parentheses. Okay, now I'm going to take half of the negative 2, half of it and square it, that's negative 1. And negative 1 squared is positive 1, so I'm adding 1 in here, inside the parentheses. But it's really not a positive, it's really a negative, because if I redistributed that negative to all the terms, that would be a negative 1. So I've effectively subtracted 1 on this side of the equal sign. So therefore, I must add 1 so that I've not changed the value of the equation. All right, so when this is important, right? It looks as though I'm adding 2, but I'm not. This really is subtracting 1, so I must add 1 not to change the value. All right, I end up with my binomial squared. It's x, whatever, plus or minus the value of b, and it's negative 1. I combine these, it's 3. What is my vertex? It's 1, 3. Opposite, same. So graphing it on the xy axis, if I go over, probably needed to make this a little, maybe I'm good. That might be good. 1, 2, 3. We'll go up 4. Maybe we'll just wait, it opens down, so I better go down here, right? Okay, here's my vertex. All right, I'm gonna go ahead and ask myself, what's my axis of symmetry? Axis of symmetry is x equals 1. Whatever that x value is, that's my axis of symmetry. All right, so my vertex is 1, 3. That's 1, 3. I'm expecting to go down, because remember I said it opens down. Here's my axis of symmetry at x equals 1. I have where it crosses the y-axis. All right, and what can I do? I can plot a mirror image of that on the other side of the axis of symmetry. So if I go over 1 here, I can go over 1 more here. And that is the parabola. Okay, let's do one more example from the book. Let's write this vertex. 1, 3. And I'm just going to go back and show you in a little bit how we can find that without completing the square, so you can check yourself. All right, example 3 is y equals negative x squared minus 6x minus 8. All right, I'm going to answer those 2 questions. Opens up or down? It opens down, right? Opens down. That's what I'm expecting. What's my y-intercept? It's going to be 0, negative 8. All right, I isolate my negative 8 by itself, Because I have a negative here, I factor out the negative out of the parentheses, changing all the signs within the parentheses. I take half of 6, which is 3. I was writing 3 instead of squaring it. And then I square it, so 3 squared is 9. I'm adding 9, but remember, because of this negative, if I redistributed that negative, it'd be a negative 9. So it's a negative 9 in here, so I'm going to add 9 so that negative 9 plus 9 is 0. I don't change the value. When I get my binomial here, it's x plus or minus b over 2, which is 3. I combine 9 and negative 8, which is 1. My vertex is opposite, same. Opposite, same. Negative 3, 1. Opposite. Because this is really x minus the value of negative 3. Look, x minus the value of h. Okay? All right. Now, when I graph it, I'm going to start with the vertex. We always start with the vertex. So it's going to be negative 3 and 1. What's my axis of symmetry? My axis of symmetry is that x equals negative 3. I'm going to draw that. All right. Where, I'm going to have to make some more room over here. 1, 2, 3. That'll be negative 6. Now, I'm going to go all the way down to negative 8 and plot 1, 2, 3, 4. That's negative 4. 6, 7, 8. That's negative 8. Here is my y-intercept. If I go 3 units to the axis of symmetry, I can go 3 more and plot a point at negative 6, negative 8. And it opens down, so this parabola graphed looks like this. Okay? Now, I said I was going to show you another way you could find the vertex. All right? So let's go back to the equation. I'm going to write both the equations from example 1 and 2 on the board. All right? So going back, this was y, this is 100.1, y equals x squared minus 4x plus 2, and 100.2 was y equals negative x squared plus 2x plus 2, plus 2x plus 2. All right, now, remember, our quadratic formula is x equals the opposite of b plus minus the square root b squared minus 4ac all over 2a. Okay, remember what was under the radical? It is our discriminant. It tells us what type, real, rational, irrational, imaginary. It tells us what types of solutions and how many, all right? The other part, the opposite of b, over 2a, that gives us the x value of our vertex, okay? So our vertex is going to be the opposite of b over 2a, and then it's going to be the y value when I plug that in, okay? So let's do that here. The x value. The x value of my vertex is going to be the opposite of 4, which is 4, all over 2a, which is 2. All right? So you can check yourself. I'm going to go back to black. It's seen better. All right? Now, what is this? F of that value. So now I want, remember, F of x is the same thing as y. So I'm just doing F of 2 equals, and I'm plugging in 2 here. It's 2 squared minus 4 times 2 plus 2. So f of 2 is 4 minus 8 plus 2. So f of 2 is negative 2. Look. It gives me my vertex. All right, let's do it with this equation. All right, so opposite of b over 2a. It's the part of the quadratic formula that is not the discriminant, okay? All right, so my x value for the vertex is going to be the opposite of b, negative 2, all over 2 times negative 1, right? That's negative 2 over negative 2, which is 1. That's what I got. To find the y value, I do f of 1. That means I plug 1 in to the equation and solve. So it's the opposite of 1 squared plus 2 times 1 plus 2. F of 1 is negative 1 plus 2 plus 2. That equals 3. 4 minus 1. That's my vertex. Okay, work your practice problems and your homework, and I'll see you soon on live video.